will see example number 8. See, here we are not going to discuss the example number 6 and 7 because both have same logics as discussed with the previous numericals. In example number 6, we are using this sin a plus b logic, and in 7, we are applying this tan a plus b logic. Rest of the things are same. We will get two right angle triangle, and we have to find the values of sin a cos a, sin b cos b, and we have to place this in this equation and find the right hand side. So means ultimately we have to shift this sign on the right hand side and making this sine inverse value, and this tan, shifting this tan on right hand side and making this in tan inverse form, and we will get the solution. So now we will discuss the example number 8. We have to prove here that the value of tan inverse of under root x is equals to 1 half of cos inverse of 1 minus x upon 1 plus x, where x belongs to 0 to 1. So here cos inverse of 1 minus x upon 1 plus x is given. So it is somewhere near in this form cos inverse of, suppose in place of x I am writing tan square theta. So this will be 1 minus tan square theta upon 1 plus tan square theta. So this 1 minus tan square theta upon 1 plus tan square theta will be our cos 2 theta. So ultimately we will get cos inverse of cos 2 theta. So from this we are applying the logic that suppose we are assuming x is equals to tan square theta. So our under root x will be tan theta. First we will solve this left hand side. So tan inverse of, suppose under root x we are writing tan theta. So it will be tan inverse of tan theta will be theta. This is our left hand side, and for this right hand side, cos inverse of this 1 minus tan square theta upon 1 plus tan square theta will be cos 2 theta. Here 1 half cos inverse is given, so 1 half cos inverse of cos 2 theta, which will be 1 half of cos inverse of cos 2 theta will be 2 theta, hence here theta. So from this our left hand side is equals to theta and right hand side is also is equals to theta. So LHS equals to RHS. But here we have to show that why we are making this cos inverse of cos 2 theta equals to theta and tan inverse of tan theta is equals to theta. So here x belongs to 0 to 1 is given. So suppose x is 0 to 1 is given. Now here we have assumed under root x. So when we are making under root here, so this will be under root x less than equals to 1. Now in place of under root x is equals to tan theta. So tan inverse of under root x will be, suppose here tan inverse 0 and tan inverse of under root x is less than equals to tan inverse of 1. Now tan inverse 0 will be 0. In place of tan inverse under root x we are placing theta, and tan inverse 1 will be pi by 4. So this theta belongs to 0 to pi by 4. So this, suppose theta belongs to this 0 to pi by 4 in this closed interval form, which is actually a subset of minus pi by 2 to pi by 2. So only under this condition we can write tan inverse of tan theta equals to theta. And this for 2 theta, suppose multiplying this whole equation with 2, so we will get 0 less than equals to 2 theta less than equals to pi by 2. So this 2 theta belongs to 0 to pi by 2, which is actually a subset of 0 to pi. Hence for this 2 theta, in place of cos inverse of cos 2 theta we can write 2 theta, and plus for this theta belongs to 0 to pi by 4 we can write tan inverse of tan theta equals to theta. And only under this condition our LHS is equals to RHS, we can write this in this form. Example number 9. So here we have to prove the value of cot inverse of under root 1 plus sin x plus under root 1 minus sin x upon under root 1 plus sin x minus under root 1 minus sin x v equals to x by 2 and x is given, it is belongs to 0 to pi by 4. So here we will try to make it in the form of cot inverse of cot theta, then we can write this theta. So first we will solve this under root 1 plus sin x. Suppose this under root 1 plus sin x is given. So here we will use two equations. The one will be sin square x plus cos square x equals to 1, and another will be sin 2x equals to 2 sin x into cos x. Now here sin x is given, so when we are dividing this theta by 2, so we will get 2 sin x equals to 2 into sin x by 2 into cos x by 2. Now placing all this value here, so we will get, in place of this sin square x plus cos square x, we are placing the value of sin square x by 2 plus cos square x by 2, because ultimately it will give the same result, that is 1. So now sin square x by 2 plus cos square x by 2 plus this sin x will be 2 sin x by 2 into cos x by 2. So ultimately it is in the form of a plus b whole square. So we will write like cos x by 2 plus sin x by 2 whole square. Now this under root of square is given, so finally we will write it like cos x by 2 plus sin x by 2. Here we are assuming cos x by 2 plus sin x by 2, not this sin x by 2 plus cos x by 2. The reason behind this is this: suppose for this under root 1 plus sin x, we are getting cos x by 2 plus sin x by 2. So for this under root 1 minus sin x, rest of the logics will be same. Finally we will get under root of cos x by 2 minus sin x by 2 whole square. So it will be mod of cos x by 2 minus sin x by 2. See, this value of mod will not be less than 0. Okay. So here x belongs to 0 to pi by 4 is given. So for when we are looking for this cos and sin function between 0 to pi by 4, the value of cos theta will be always greater than this sin theta when we are talking about this 0 to pi by 4, because cos 0 will be 1 and sin 0 will be 0. Now this cos, this 30 will be root 3 by 2, and this sin 30 will be 1 by 2. So in both these cases, for between 0 to pi by 4, the value of cos is greater than sin. Hence in this we are placing the cos x by 2 first and sin x by 2 later. And since here x belongs to 0 to pi by 4 is given, so for this x by 2 will be belongs to this 0 to pi by 8. And in this condition also cos theta will be greater than sin theta. Hence in this we are placing cos x by 2 minus sin x by 2. Now placing this value in our example. So here cot inverse of under root 1 plus sin x will be mod of cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. So it will become cot inverse of this 2 cos x by 2 upon 2 sin x by 2. So this will be cot inverse of cos upon sin will be cot x by 2 and cot inverse of cot x by 2 will be x by 2, which is our RHS for this example. Example number 10, here we have to prove that the value tan inverse of under root 1 plus x minus under root 1 minus x upon under root 1 plus x plus under root 1 minus x to be equals to pi by 4 minus 1 half of cos inverse of x. Here hint is given, that is take x equals to cos 2 theta, and the interval of x is from under root minus 1 by 2 less than equals to x less than equals to 1. So now placing x equals to cos 2 theta, so this will be minus 1 by root 2 cos 2 theta, and this will be 1. Now placing this minus 1 by root 2 in cos form, so cos pi by 4 is equals to 1 by root 2, and since here minus 1 by root 2 is given, so our theta will lie in this second quadrant. So this will be minus 1 by root 2 will be cos 3 pi by 4, and this cos 1 will be, for value of cos 0 the value will be 1. So placing this in cos form, so we will get it like cos 3 pi by 4 less than equals to cos 2 theta less than equals to cos 0. Now when we are eliminating this cos function, the sign will get reversed, because the cos function is decreasing function in first quadrant. So this will be 3 pi by 4 greater than equals to 2 theta greater than equals to 0. So ultimately this theta will, when we are dividing with this 2, we will get 3 pi by 8 greater than equals to theta greater than equals to 0. So from this ultimately we can write theta belongs to 0 to 3 pi by 8. Now we are replacing x equals to cos 2 theta in this equation and solving it further. So by this process we are getting the interval of theta, that is belongs to 0 to 3 pi by 8. So here we will write theta belongs to 0 to 3 pi by 8. Now here tan inverse, in place of x we are placing under root 1 plus cos 2 theta minus under root 1 minus cos 2 theta upon under root 1 plus cos 2 theta plus under root 1 minus cos 2 theta. In place of 1 plus cos 2 theta, we are applying this equation, that is 1 plus cos 2 theta will be 2 cos square theta, and this 1 minus cos 2 theta will be 2 sin square theta. So placing this value here, we will get, in place of 1 plus 2 cos 2 theta, 2 cos square theta, and this will be 2 sin square theta. For this denominator part, this will be 2 cos square theta plus 2 sin square theta. So taking under root 2 common, finally we will get tan inverse. This is in the form of under root of square, so it will be mod of cos theta minus sin theta upon mod of cos theta plus sin theta. So from this we are finally getting tan inverse of this. Suppose we are taking this cos theta common, so we will get 1 minus, this will be sin theta upon cos theta, and this will be 1 plus sin theta upon cos theta. So it is in the form of tan inverse of 1 minus tan theta upon 1 plus tan theta. So in place of now 1, we are placing the value of tan pi by 4, because tan pi by 4 is equals to 1. So finally this can be written like tan inverse of tan pi by 4 minus tan theta upon 1 plus tan theta into, here placing 1, and in place of 1 we are writing tan pi by 4. So finally this equation is in the form of tan inverse of tan pi by 4 minus theta. We are writing it here. Ultimately this can be written like tan inverse of tan pi by 4 minus theta. So here we can write tan inverse of tan pi by 4 minus theta equals to pi by 4 minus theta. But before that we have to prove that whether this pi by 4 minus theta belongs to minus pi by 2 to pi by 2, because that would be the requirement for this tan function. So since our theta belongs to this 0 to 3 pi by 8, so first we will write like 0 less than theta less than 3 pi by 8. Now here pi by 4 minus theta is given, so multiplying whole equation with minus, so the sign will get reversed. So here will be minus theta and minus 3 pi by 4. Now adding this with pi by 4, so this will be pi by 4 greater than pi by 4 minus theta greater than pi by 4 minus 3 pi by 8. Here it will be 8. So now solving this, pi by 4 greater than pi by 4 minus theta, and for this 8 will be the LCM and this will be the 2 pi minus 3 pi. So ultimately this will be pi by 4 greater than pi by 4 minus theta greater than minus pi by 8. So our theta will belong to this minus pi by 8 to pi by 4. From this condition we can see that pi by 4 minus theta belongs to minus pi by 8 to pi by 4, and since this is our subset of minus pi by 2 to pi by 2, hence in this condition for tan inverse of tan pi by 4 minus theta we can write pi by 4 minus theta, and when in place of theta we are placing the value, so x equals to cos theta, so this will be pi by 4 minus this x equals to cos theta, so 2 theta will be cos inverse of x. Here suppose 2 theta is equals to cos inverse of x, hence theta will be 1 half of cos inverse of x. So in place of theta we are writing this 1 half of cos inverse of x, hence it is our right hand side. So we are getting this final right hand side value for this example.